Tahoe physics students, mostly absent physics students. This short video is going to show you what we did in our lab. I'm going to post some data from the measurements that we made, and then you can analyze and catch this thing up. It's a really important concept, though, between the relationship of work and energy, in this case kinetic energy, the motion, the energy of motion of this cart. So the experiment's pretty simple. We've got two tools, two measurement devices. We're going to measure the force that we pull the cart with the force sensor right here, and we've used this several times. And we're also then going to measure the force that pulls over a predetermined distance. So I've got some marks of tape on here. In this case it's 60 centimeters or 0.6 meters. So the force is pulling that distance. Force times distance is work. We're also going to take note of or measure the change of velocity with the motion detector here. So we're going to start with zero velocity. For us that means zero kinetic energy. And we're going to allow it to accelerate. We're going to allow work to be done to it, and it's going to change its kinetic energy. So we'll run that through there. But you'll notice what happens. As soon as the cart reaches this level, the rope goes slack, the weight hits the ground. So what that means is that there's no more work being done on the cart after it passes that tape. So it's going to be moving under its own inertia, and the motion detector will tell us its velocity. So essentially, we start with zero kinetic energy. We do work on the cart by applying a force over this distance. The force stops, the work stops, and we've changed the cart's velocity. We've changed its kinetic energy. What we're after today is to learn a little bit more of the specifics, the mathematics that relates the amount of work done to the final velocity of the cart. So we'll take a look at some data of what that might look like.